So on 33, they tell us diagonals of a rhombus are 12 centimeters and 16 centimeters. So if I draw a rhombus, perfect. This diagonal, they tell us is, the whole thing is 12 centimeters. 12 centimeters. This diagonal, 16 centimeters. Remember that the diagonals bisect each other, all that stuff, but they're telling us that whole diagonal each way, one is 12, one is 16. If they do bisect each other, what's this part from here to there? 8. How about this part? 6. Same thing, 8 over here, 6 over here. What do you know about these angles if it's a rhombus? They're right angles. So what kind of triangles do we have there? Right triangles. If I split off one of those right triangles, this side's 6, this side's 8, how could we find that third side, which is one of the sides of the rhombus? Pythagorean's theorem, you could use a squared plus b squared equals c squared. You gotta remember Pythagorean's theorem, SOHCAHTOA, all that stuff that you could use with right triangles. Easier way on this one. This actually fits one of the families that we talked about. Does anybody realize which family it fits? What were the families? Anybody remember any of them?
It's like 1, 2, 3, 4, 5.
That's the key one. That's the one that's used the most. And guess which one this one fits? 3, 4, 5. Can anybody tell me how long this side is? 10. Because all they did was doubled each one of them. If you double each one of those, this side's 10. What did the problem ask us to find?
The perimeter.
So how would we do that? 10 times 4, because what do you know about the 4 sides of a rhombus? They're all equal, so what's the perimeter? 40 centimeters. Next question. Sixteen.
What number was that I just did?
33. Problem 16. Shape looks something like that. This is X. This is Y. Z. W. They got the diagonals drawn in there. And this is B. They tell us that this angle is 53 degrees. And what else do they tell us? VW is 3. XB, that's this part right here, is 2A minus 2. And ZB, which is this part, is 5A plus 1 over 4. Tried to make it hard on you, giving you a fraction. I'm not even, I don't have any idea what 16 said, and I really don't care. Can we go through here and find all this stuff? Whole bunch of different things? Yeah. First thing, easy thing, if this is 3, what's this part up here? 3, so VY is 3. If this angle is 53, the diagonals of a rhombus do what to the angles? Make them equal, bisect them. Does that work for a parallelogram or a rectangle? No, it works for rhombus and a square, and that's it. So make sure you don't get the properties all confused. So if this is 53, what's this up here? What's this angle down here?
53.
This angle?
53.
Now, if we're looking at this rhombus, how much is this whole angle? Angle W? 106. What do you know about angles that are right next to each other, consecutive angles? They add up to 180. So if that's 106, what's this angle up here have to be? 74. Well, over here, we got it split up. How would you find each of these two angles? 74 divided by 2, what is that? 37. 37. What's these two angles down here then? 37, 37. We didn't even do probably the easiest one. What's these middle angles in here? They're all 90. If it's a rhombus or a square, they all have to be right angles. What's the last thing that we could find? Well, actually, there's more things we could find, but what's the last thing that's sort of easy? What do you know about these two segments? They have to be equal to each other, so 2a minus 2 has to equal 5a plus 1 divided by 4. Now, lots of different ways you could do that problem with that fraction in it. Probably the easiest way, since we've been doing it for about the last 3 chapters, if I put a 1 underneath that, what do we have now? What's this whole thing called? Proportion. You could put parentheses around this, parentheses around that, and cross multiply.
What's the point of cross multiplying, not just
What, here?
yeah.
Well, so then you just write that down. If you know that, then you just write that down. But when I cross multiply the other way, I get 4 times 2a minus 2. What do I have to do here? Distribute, good. Somebody tell me what that's gonna give me.
4 times 2 is 8. 4 times negative 2.
4 times negative 2 is what?
Is it negative 8?
Yep. Now what do you do? Subtract the a's, get all the a's on one side. These cancel. 3a minus 8. Then what? Add 8. What's that gonna give us? 9. So what's a equal? 3. If a equals 3, can we go back up here and find these two? 2 times 3 is 6 minus 2. So that one's 4. What's this one down here have to be then? 4. The only thing we haven't found, I don't know, does any of the questions ask you to find that side?
I just asked this
So we found that. Did any of the rest of the questions, how many questions was it, 16 through 19? Did one of them ask us to find any of these segments, XW or XY or YZ or ZW? They did. So if we had to find the outside, we know that we have a right triangle here.
That's 5.
let's-
It's a 3.
Okay, so let's, if I split this off, we know it's a right triangle. This side's 4, this side's 3. What's this side out here have to be? 5. If they ask you to find the perimeter, what's the perimeter gonna be? 20. All right, so we found everything possible, every angle, every segment on this whole thing. How long is segment XZ? XZ, 8. What's the measure of angle YZW? 74. Make sure you can find all that stuff. You know, sometimes you might have to add these two together. Sometimes you might have to add these two together, whatever it is. They may even ask you something silly like find the perimeter of that triangle or something. You have all the information there. You just got to know what to do with it. If the what do you know about these 4 triangles, all 4 of them? What's true about all 4 of them as they relate to each other? They're all equal, they're all congruent to each other. Other questions? Say it again. 49. 49. So they're telling us that's a rectangle, then they stuck this triangle on the side of it just to try to make it a little tougher on you. Use rectangle LMNG. They also telling us that, wow, maybe I should redraw this because I didn't see it, but they tell us the other shape is a parallelogram. Still looks terrible. Right, so they tell us that this is a rectangle. Then they tell us,
Isn't like J to the left?
yeah, but it's still this point right here, so. Then they tell us that, let's see, LKMJ, that this, which my shape doesn't look too good, is supposedly a parallelogram. And 49 says angle PLK, that's this whole angle right here, is 110. And they want us to find angle LKM, which is out here. So that's the angle we're looking for. What do you know about this angle? 90. All right, so what's this angle out here? Just this part outside. If that whole thing's 110, this is 90, that part is 20. What's this angle down here have to be then?
20.
Can we now find this angle over here? 3 angles of a triangle have to add up to be how much? 180, so that angle has to be 140. What's this angle over here have to be right in the middle here? 140. Remember, this is a rectangle, not a rhombus or a square, so the diagonals aren't perpendicular to each other. What's this angle right here? 40. What's this angle up top here? Right here. 40. 140 over here, vertical angles. Let's see, could we find any of the other angles? Can we say that each of these is 45?
Yeah.
Only if it was a what? Instead of a rectangle, if it was a square, then we could. Alright, the diagonals don't bisect the angles unless it's a square or a rhombus. So we can't for sure find each one of those with the information that we have right now. At least I don't think. Let me think for a second. So we can't find each of those angles with just the information that we have, but we found what they wanted anyway, so. Other questions?
23.
23. 23. All right, so they give us coordinates for a grid, again, on the test. Quite a few problems about coordinates and stuff, so watch carefully on this one. Given each set of vertices, determine whether the shape is a rhombus, rectangle, or square. List all that apply. Explain your reasoning. Remember, first thing you're going to check, it's got to be four-sided. Then you're going to check, see if it's a parallelogram. Well, the way we could tell it's a parallelogram, you had those 5 ways to prove it, but the easiest way opposite sides are parallel. So we're gonna probably, if we're on a coordinate system, have to find what for each side? Slope. And that's a guarantee on the test, that's what I want you to do. Then we'll decide if it's a rectangle. If it is a rectangle, do we just stop there and say, that's it? No, then we check to see if it's a rhombus. If it's both of those, what name do we give it? Square. So give me a second so I can graph it. -2, -1. If I graph something wrong, please tell me. -2, -1. That's point B. -4, 3. Guessing that's F. 1, 5. That is G. And 3, 1. H. So if I connect all those, of course, Bailey, the first thing you do is you look at the way my shape looks, right? And you say, man, that looks like a rectangle. So you just write down rectangle. It's got to be a rectangle. Mr. Eversole always draws everything so perfect. So we look at that. First thing we want to do, decide whether it's a parallelogram. To be a parallelogram, the easiest way, we could use the distance formula and find the length of each side and do all that stuff. It's too much work. We use the slope formula, and to find the slope of this side, just count your rise over your run. And this is what I would want to see on the test. Something like this maybe. For this side, if you go from 3 up to 5, what's your rise? 2. So you go up 2, and your run is -4 over to 1. So how much did you go over? 5. So that's the slope of that side. Well, what should the slope of this side be then? 2 over 5. So let's find it real quick. If I draw in that, from -1, remember you're doing your y's first. From -1 to 1, how much did I go up? 2. From -2 to 3, how much did I go over? What's that tell us about these two? So those sides are what? Parallel. The slopes are the same, then they have to be parallel. Is that enough to say it's a parallelogram? No, we got one pair of sides, we got to do the other pair of sides. On this one, slope of that side, from -1 up to 3, how much did I go up?
4.
Be careful now. From -2 over to -4, how much did you go over? -2. Now, if you were normally doing the slope, you should reduce that. I don't care if you reduce it now, because when we get the other one, it should be the exact same thing, 4 over -2, right? So we could just leave it that way, and we know that they're the same, or if they're not the same. For this one, from 1 to 5, how much did I go up? 4. From 3 over to 1, be careful, how much did I go over? -2. What's that tell us about those two sides? They're parallel to each other. These other two were parallel to each other. So our parallel, well, if these two sides are parallel, these two sides are parallel, what do we know it is? So we know it's a parallelogram. Now I'm going to use a symbol for a parallelogram, since that's the only one we have. Now, do we just stop there then? No, now we check to see if it's a rectangle. The way we can check to see if it's a rectangle is go right back to these slopes But look at this slope and look at this slope. Look at two slopes that are right next to each other. And they should be opposite reciprocals of each other. Are those two opposite reciprocals of each other? No. So what I'm going to say is not opposite reciprocals. So this shape is not a what? So we know it's not a rectangle. Do we just stop then and say the best name is a parallelogram? All right, we have to check, see if it's a rhombus. Easiest way to check, see if it's a rhombus, draw in the diagonals and find the slopes of the diagonals. Let me change color here so we can actually see this. So let's find the slope of that diagonal. If we go from 1 up to 3, how much did we go up? 1 to 3? 2. If we go from 3 over to -4,
Negative 7.
or I'm sorry, let's see, did I do that right? -7. So, how do we do that? So 2 over -7. What should be true about the diagonals if this is a rhombus? What should be true about all these angles? This should be perpendicular. So again, these diagonals should have slopes that are opposite reciprocals of each other. So let's find the slope of this other one. We're going from here to there, from -1 to 5. How much did you go up? 6, good. And from -2 to 1, how much did you go over? 6 over 3 and 2 over -7. Are they opposite reciprocals? What is the opposite reciprocal of 6 over 3? -3 over 6. What's the opposite reciprocal of 2 over -7? Close. Just 7 over 2. Get rid of the negative. All right, so they're not opposite reciprocals. So the diagonals are not perpendicular. Well, if the diagonals are not perpendicular, it's not a rhombus. What's the only name we can give it? Parallelogram. So this shape is a parallelogram. It's the best name we can give it. I think the ones on the test, most of them, I just ask you, a couple of them, I ask you to decide what shape it is and show me the work and explain. One of the harder ones on the test, I know I say, show me that this is a parallelogram. Well, to show me it's a parallelogram, all this stuff that we did at the beginning, you need that. Show me the sides are parallel and then say, hey, since these two slopes are the same, we know they're parallel. Or these two slopes are not the same, so they're not parallel. All right, today is the, what is today, 7th? Today is the 7th. Go ahead and start copying this down. Cover 2 other shapes, and we're going to add them to this picture over here, so you might want to finish out your picture. We're going to finish it out today. We'll move this 4 sides. One of the shapes we're going to add, trapezoid. Actually, we're going to add 3 shapes today. Notice a trapezoid. It doesn't fit in with all this other stuff that we've been doing. So it's like that person in your family that you think, oh yeah, they're like, oh, it's off to its own. It's the way I am in my family. Nobody likes me. So it's out here all by itself.
You're exaggerating.
So we're gonna use properties of a trapezoid, be able to give the best name for a quadrilateral. So again, what you're gonna have to do, you check to see if something's a parallelogram like we just did. If it's not a parallelogram, you can't just stop now and say it's a quadrilateral. If it's not a parallelogram, then you gotta go check to see if it's a trapezoid.
So do I like label this trapezoid?
Yeah, I didn't give it a title, did I? Guess I should be writing with my pen, so. Now, with my slideshow here, please make sure that you realize a trapezoid, and when we talk about the definition here in a second, we'll explain exactly what it is. But a trapezoid could look like this. Trapezoid could look like that. Oops, maybe not quite like that, like that. All that has to be true about a trapezoid is it has to have two parallel sides. So over here, to be a trapezoid, the key thing, two parallel sides. Not two pairs of parallel sides, but just two parallel sides. So you've got all kinds of different ways a trapezoid could look, but the whole point of me saying that is on my slideshow, on the computer, I'm only smart enough to draw one kind of trapezoid. So don't think that every trapezoid looks like that. All right, so a trapezoid is a quadrilateral with one pair of parallel sides. You've got to make sure it's just got one pair. If it's got two pair of parallel sides, then it would be a parallelogram. So again, a trapezoid could look like this. These are just the normal two trapezoids that we use a lot. Could look like that, where these two sides are parallel. Could look like this. And this is going to be a special trapezoid that we're going to talk about. It also could look like that. Parallel sides don't have to be the top and the bottom, they could be the sides. But it's just got two sides that are parallel, the other two sides are not parallel. All right, on this shape, this is our trapezoid. We're going to put a whole bunch of stuff in here. Just know this, or know that this is a normal looking trapezoid. Again, this is a special kind of trapezoid that we're going to talk about here in a minute. And it's the only one that I know how to draw on the computer, so that's why it looks this way. These two sides are your parallel sides. And we're going to talk about what they're called. These other two sides are called something else, and then there's certain properties that it has. All right. First property of a trapezoid, go ahead and draw this picture. And if you wanted, you could just label all this stuff as we go through. It might make it easier.
I just drew it like Mommy did on my list.
That's all right. Then you just have to You'll have to draw in this line here, or this segment here, because we'll be calling it something too. So AD, it's called a base, that's one of the parallel sides, and it's parallel to BC, that's the other base. So a trapezoid has two bases. And they're always parallel to each other. These other two sides, this side over here, it's called a leg. That's a leg. This side over here is a leg. So the two sides, that aren't parallel, not parallel, the two sides that are not parallel are called the legs. Sometimes they're congruent to each other. Anybody have any idea what this trapezoid would be called if these two legs were congruent to each other? In a triangle, if two sides were congruent, what kind of triangle was it called? Isosceles. Guess what a trapezoid is called if its two legs are congruent? Isosceles. We're going to talk about that here in a second. EF, the segment that runs right through here, is called the median if E and F are the midpoints of the legs. So this is a midpoint. This is a midpoint. Then this is called the median. Have we had several different kinds of medians this year? Yeah, there's all kinds of medians in math. So don't get them confused. This is the median of a trapezoid. We had a median of a triangle. We had mean, median, and mode. So all kinds of medians.
I'm sitting over there, so I can see.
Oh yeah, you can scoot over farther if you want. I'm just scooting the desk over because everything gets shoved that way all the time. You can see if you sit over there in those two rows like where Sierra and Alexis are, people right on top of them in that. So the median here connects the two midpoints. Remember, the median of a triangle went from a vertex to the midpoint of the opposite side. So it's sort of the same, except now you have two midpoints and you're connecting them.
Do you have tissues to do?
Did that. I'll find you some. Median, this median, write this down. This is real key right here. This is one of the rules. I guarantee that on the next test, we're going to use that rule. Because that's one of the key ideas about trapezoids, and it's probably the key idea about a trapezoid. So, you're welcome. So the median is parallel to the bases. So these two bases are parallel. Well, the median's also parallel to those two. And this is the key. This is one that it's real easy. So I put it on tests and quizzes, everything else. And is equal to half the sum of the bases. So if you wanted to write down a formula for this, it'd be base, and we could call it base 1 plus base 2, it doesn't matter which one's 1 or 2, divided by 2, that's always going to equal the median. So the length of the median is going to be this plus this divided by 2. So if I told you this base was 52, this base was 20, you should be able to find the length of that median. You just add those two, 52 plus 20, and then divide that answer by 2, and it's going to give you how long that median is. What do you notice about this shape right here? What kind of shape is it? Smaller trapezoid. How about this shape down here? Smaller trapezoid. Guess what would happen if I drew the median in for this smaller trapezoid? What kind of shape would this be? Another trapezoid. This one would be another trapezoid, so on and so on. Then you could keep going and going and going and just have more and more trapezoids. So the median's parallel to the other two, to the two bases, and it's also half whatever the two bases are added together. Now we had something earlier this year, I probably shouldn't even mention it. If you have a triangle and you connect the two midpoints, it wasn't called the median, but what was true about the length of that compared to the length of that third side? It was half. So it's sort of the same thing as here, because all you would do here, if you finish this out and made a triangle down there, that's where that is coming from. What was that called? I don't remember. Usually I don't forget things, but what was this segment called? Had an easy name, I'm sure, because math. Nobody remembers? That's not good. About a mid segment, was that it?
You don't remember either.
No, I do remember. I was just kidding. It was a mid segment. So for a triangle, it was a mid segment. For this, it's a median. Two different names. All right. If you have a trapezoid, go ahead and write this down. Draw this picture. If you have a trapezoid where the two legs are congruent, then it's called an isosceles trapezoid. So on our little chart over here, where do you think isosceles trapezoid is going to go? It's going to come down from here, just be a smaller part of trapezoids. So you have an isosceles trapezoid. So if you have a shape and it's a trapezoid, it could still be an isosceles trapezoid. And the key about an isosceles trapezoid, it's got two parallel sides, and then other two sides congruent. So the legs are congruent to each other. So these two are parallel. The other two are congruent. Again, this is still called a base. This is a base, leg, leg, and we know that the legs have to be congruent to each other. They have to be the same.
So when we draw this little chart, then you have to draw it all what you're running outside the squares.
I would, this, all I write out here is what the key property of each one is. So for like a rectangle, what's the key property for a rectangle?
What?
For a rectangle, key property is it has 4 right angles. All right, so for an isosceles trapezoid, two pair of base angles are congruent. These are your base angles. This angle We can call this base 1 and this base 2 again if you want. This angle and this angle have to be congruent to each other. Guess what's true about these two angles? They have to be congruent. Now, this only works for isosceles trapezoids. It doesn't work for the others. So these are two base angles. These are two base angles. With this, a lot of times you got to be careful, because if they draw this, they draw their trapezoid this way. These two angles go together as base angles, and these two go together as base angles. So you got to watch and don't think of bottom and base and all that stuff. So the base angles here have to be congruent in isosceles trapezoid. Base angles here have to be congruent. Did I leave off something on that other one? Let me go back. Yeah, I did. In any trapezoid, these two angles are always supplementary. That's probably why I left it off, because there's no real way to describe it. You just got to know, hey, these are my bases. Angles right next to each other, not jumping across the base, are supplementary. These two angles are always supplementary. And then maybe one more thing about a trapezoid, just like all these shapes that we've been talking about, what's all four angles have to add up to be? All four angles of a four-sided figure have to add up to be how much? 360 degrees. All right, 360 degrees. So make sure you remember, for any of these, all four angles always add up to be 360.
Wait. Okay, never mind. I thought you were
Now I got too much junk in here, so I'm going to draw another one out here. If I can draw an isosceles trapezoid that sort of looks like that. In an isosceles trapezoid, the diagonals are also congruent. So the diagonals are always the same length. Just like in a rectangle or a square, diagonals are the same length. Difference about a trapezoid, I know my picture's not drawn real well, but if we're looking at this, is that part right there going to be the same as this part right here? No. So do the diagonals bisect each other like in all those other shapes that we've been talking about? No. But in an isosceles trapezoid, what happens? If I can draw this correctly, this part is equal to this part, and this part is equal to this part. So the two bottom parts here are equal, the two top parts are equal. So if you drew in the diagonals, if you actually had a nice drawing, this part has to equal that part, this part equals that part. And the diagonals are the same lengths total, but they don't bisect each other. They split each other up so that you have two congruent parts and two congruent parts, but they don't bisect because they don't just split in half. So don't get all those properties confused with, rhombus, rectangle, square, parallelogram, and all the other stuff. Now, the diagonals in any other rhombus, do these two parts have to be equal? No. These two parts? No. So that all this only works for an isosceles trapezoid. Right, a kite. And we're not gonna do a whole lot with the kite. On your little chart here, kite is its own separate thing out here. We're not gonna do a whole lot with the kite, so you can put an asterisk beside it or something. This is what a kite looks like. I can draw a decent one. Key idea about a kite, it's got two pairs of consecutive congruent sides. Two pairs of consecutive congruent sides. So what that means, these two sides are congruent, these two sides are congruent. Again, we're not going to do a whole lot with the kite because all it does is get confusing. Because with the definition I gave you, two pairs of consecutive congruent sides, could a square be a kite? If I draw a square, does it have two pairs of consecutive congruent sides? Yeah, but that's not what a kite's supposed to be. And kites don't get used very much. All right, go ahead and write this example down. Just write down those numbers. We're going to graph it. And then we're going to decide what shape it is out of all these. Pick up the pace. So we got -3, 2. That's Q. We got -1, 6. That's R. S is 4, 6. And T is 6, 2. So our shape looks something like that. Well, if you graph this, you can probably tell which side of this chart are we going to be on. It looks like if we're anywhere close to our graph being correct, looks like where should we start at? See if it's a trapezoid. To see if this is a trapezoid, what we're going to do is we're going to look at RS and we're going to look at QT and we're going to find the slopes of each one of those. For R and S, remember M stands for slope. For R and S, if we look at the Y's for R and S, how much does it go up? If you go from 6 to 6, how much do you go up? None, 0. Well, that tells us that this segment is special because what kind of segment is it? Horizontal. What's the slope of any horizontal line? 0. Look at QT. Does it go up any? No, so the slope of it is also 0. What's that tell us about those two? They're parallel. Since the slopes are the same, they have to be parallel. So we know those two are parallel. Now what we need to do with the other two, because maybe my shape's drawn completely and totally that bad, but we need to show that it's not a parallelogram. Well, these other two, if it was a parallelogram, would have to be parallel to each other. So let's look at RQ and ST and find the slopes of them. RQ, what's the y's for RQ? How much do we go up if we go 2 to 6? Or QR? 4. From -3 to -1, how much do we go over? Excuse me. 2. Now let's do ST. From 6 to 2, how much do we go over? -4, right? From 4 to 6, how much do we go over? Now be careful, are those the same? No, not quite. So you gotta really be careful when you're doing that. Sometimes they'll look like that and they'll look like they're the same. Not the same. So those sides are not what? Parallel. So we know it's a trapezoid. But what else could it still be? We know it's a trapezoid, what else could it be? It could be isosceles. Yeah, her. How are we gonna tell if it's an isosceles trapezoid? If those two have the same what? Lengths. And so what we gotta do is you gotta use the distance formula on RQ and the distance formula on ST. Remember the distance formula? Subtract the x's, square it. Subtract the y's, square it. For RQ, what's our x's? -1 minus -3. That's gonna make that plus. Sorry, I can't read that very well. That's, yeah, -1 there. What's the y coordinates?
2 minus 6.
Let's try to do a bunch of this in our head. What's -1 plus 3?
2.
2 squared, 4. So we know that part's 4. What's 2 minus 6? -4 squared.
Oh, that's just that one.
What's 4 plus 16? 20 is not a perfect square number, so we'll just leave it that way. All right, so the length of this side over here is the square root of 20. It's gonna be like 4 point something. But we don't need to know what it exactly is. We just wanna know if these two are exactly the same. So for ST, wow. It doesn't work once you get down so far. What's the x coordinates for S and T? So 4 minus 6. What's the y coordinates? 6 and 2. What is 4 minus 6? Squared. 6 minus 2? 4 squared. 4 plus 16. What's that tell us about those two? Same length. And if that's the same length, they're the same length, what kind of trapezoid is it? It's isosceles, good. So the best name we can give it is an isosceles trapezoid. Now I don't know why it might be at some point, but if it's an isosceles trapezoid, what has to be true about the diagonals? They also have to be the same lengths. So maybe at some point it might be easier to find the lengths of the diagonals. You know, if they happen to maybe be a vertical or horizontal segment, and you could just count it. All right, write this down. We'll do this real quick. EFGH is an isosceles trapezoid with median YZ. And this should be segment YZ there. Please don't forget all your symbols. How come I don't put symbols above all these others? If you give a segment a length, does it need a symbol? Because you know it has to be a segment. What's the other things that we name with 2 letters other than segments? Lines and one other.
Oh, right.
Rays, lines and rays, all right? Can you measure a line or a ray? No, so if we're giving this a measure, we know it's gotta be a segment. Draw me a trapezoid here. It's supposed to be an isosceles trapezoid. It's EF, GH. Tell us EF is, I drew that wrong. Isosceles trapezoid with median YZ, EF. How could I have drawn that wrong? We might need to know what.
What's the G and H?
Alright, we might need to know that maybe I started in the wrong spot. With the trapezoid, does it matter? Yeah, with the other shapes, it didn't matter. Let's see, HG, YZ is 13. Nah, we're alright. So this is 3x plus 8. This is 4x minus 10. If YZ is a median, then we know Y out here is a midpoint. We know Z is a midpoint. We're gonna draw in that, and they tell us that that is 13. Now, if they just gave you, like we did earlier, they give you this, and they want you to find the length of the median, maybe that's X, and they tell you this is 10, this is 20. All you do is add those two, divide by 2. What's 10 plus 20? 30 divided by 2. So that would have to be 15. That's pretty easy. All right? This one, we got to work it backwards, so it's a little more difficult. So you're going to add these two. Let's go ahead and combine like terms. What's 3x and 4x give us? 8 and negative 10.
Negative 2.
And we're going to divide that by 2, and that should equal our median, which is 13. How do you start to solve that? A little harder equation because it's got the fraction in it. And I know Bailey loves fractions, right, Bailey?
Put a 1 in the 15.
You could put a 1 under the 13. Is that the way you want to do it? You want to do it like a proportion? You think that's the easiest?
I don't know. That's just how we did it earlier.
All right. We can do it that way. When we cross multiply,
7x minus 2.
equals 26. And then what?
You add 2.
Add 2.
Divide by 7.
7x equals, what's that, 28? Divide by 7, what's x equal? 4. What'd they ask us to find? Find x, so that's all we have to do. If they ask you to find segment EF or segment HG, then you gotta go back and plug it in there. If I drew this in and told you it was another median, could you find the length of it? Yeah, then you'd use the 13 and this length, which 3 times 4 is 12, plus 8 is 20. Add those two, divide by 2, and then you could keep going and going and going and finding all of them all the way down through there, depending on how many you want. All right, we got about 12 minutes. Write this down real quick. Page 442. Problems 9, 13, and 17. What I'm going to do is here in a few minutes, I'll give you maybe 6, 7 minutes to try those 3 problems. And you can work it out amongst yourselves if you want. And what I will do is I will take a 0 out of the grade book for you for anybody that works one of those problems on the board.
Oh, shoot.
So, take 5-6 minutes, maybe not everybody, you know,
So it's
Can you use
each
mine?
person that does it gets 0 in the notebook, or is it like everybody?
each person.
Okay.
You can use my book. The assignments on the board, after you get done with that, so take about, like I said, about 5 minutes. Work the problem, you can help each other, I don't care about that, you can, you know, if you're not sure, maybe if Natalie's doing number 9,
Do you have to do it on the board games scenario after?
you gotta work the problem out on the board. And then, I'm not giving everybody a chance. So, I mean, if you guys get in a fight and punching each other because one of you's wanting to do it and the other one wants to do it, I'll probably laugh for a minute and then I'll probably break up the fight.
Oh. Well, I don't think that's me.
It might take me a while to get to the fight though, because I'm only expect it. But what I start to say, if one of you does 9, then somebody else maybe do 13, so you're not doing the exact same problem. Yes? Yes. All right, thank you. Don't forget, binders due Fridays, the next class.